Hello. In today video we will discuss about vfork. vfork API. It is same as fork API. Means the purpose of using vfork is also creating the child process. But we are having some certain differences with respect to fork and vfork. See that the next point, it is intended to create the new process when the purpose of new process is to execute a new program. That means in fork it is not mandatory to execute the new program compulsory, but in vfork what happens, the created child process should execute the new program by calling the exec function. We discuss the exec function shortly here. The vfork function creates the new process just like fork without copying the address space of the parent into child. Just to highlight this point, because in fork what happened, all the address space is copied into child process and later on it is shared between parent and child. But here the computer is not copying the address space of the parent to child. Then later on the child process may call the exec or exit after the vfork. The only point here, the child runs in the same address space as the parent until it calls the either exec or exit, which means that currently the child process is using the address space of the parent before calling the exec function or exit. And one more point is that vfork guarantees that child runs first until child calls the exec or exit. Means, as we know that in this case compulsory child start executing rather than the parent, but there is in the fork what happened, there is an options. So this is an example with respect to the vfork. Just one point I wanted to highlight here, both fork and vfork examples are same. Okay, only additional thing is that we are calling here exit function to terminate the child process and allowing the parent to continue as usual. Then later on the parent process is also executing, terminated by calling the exit of 0. But one thing you keep in mind, here we are calling the underscore of exit and we are calling the exit. So underscore exit directly returning the kernel to the kernel without making any cleanup process, and here there is a cleanup process by the parent process. Just we can find before vfork means before vfork, what is the PID? So this is the value. Then what is the value? This one. Means this all the things are belonging to the parent process only. All are belonging to the parent process only. Okay. Then here what happens? If I get the child process after the fork, then we are getting, obviously these are the different values. Okay. Then exit functions, already we discussed about this one. To terminate any process we are using the exit function, but there is a two termination, abnormal termination and normal termination. In normal termination what happens, either we are calling from main with the return value, I think already I discussed this point, and calling the exit. So it is we are calling the exit handlers, underscore exit we are calling the exit functions. Okay. In abnormal termination is that we are forcefully terminating a particular process. In this case we are calling the abort functions, or we are calling the certain signal to terminate the process. The ultimate goal of the exit function is that terminate the process. The exit status used to notify parent how child is terminated. Yes. So this point indicates that a particular status of the process we are using, I mean the parent is using here to notify that how exactly the child is terminated. When a parent terminates before the child inherited by init process, means already we discussed init is always parent for all other processes. Means if suppose the parent process is terminating before the child here, usually what happens, parent will terminate later on after all the child processes are terminated. If some cases what happens, the parent terminates before the child, in that case obviously the child parent will become init process. If the child terminates before the parent, then the information about the child process is obtained by the parent, okay, by executing the one of the API, that is wait or wait PID. The information consists here. What kind of the information is retrieved by the parent? There is a PID of the child process, then termination status, amount of the CPU time taken by the process. So these details will be fetched by the parent process. A process that is terminated but whose parent has not yet waited for it is called zombie process. Means sometimes what happens, a particular child process is waiting for the parent, but its parent is not waiting for its child. In that case, obviously the child process entered to one state, that is what I can call as a zombie here. When process initiated by init terminates, it does not become a zombie. Means and sometimes what happens, that even though the parent process not waiting for the child process, in that case, if suppose child process suddenly adopting the one parent that is innate, in that case child will not become the zombie here. Wait functions. Usually wait functions are executed by the parent to get the termination status of the child process. See that when a child terminates, the parent is notified by the kernel by sending the one signal, that is child signal. The termination of the child is in asynchronous event, which means that these functions is only executed when the kernel is sending the one signal, that is child signal, to the parent, indicating that your child is terminated. Just retrieve the termination status. In that case only the wait function will be executed by the parent. So parent can ignore or can provide a function that is called when the signal occurs. Means it can respond in three ways by calling the wait or wait PID here. It will block, means the parent process will be blocked if all of its children are still running. I mean the child processes are still running. In that case the parent process will be blocked and return immediately with the termination status of the child process. That means already child is terminated, so in that case the parent is directly retrieving the termination status here. Next, third point, return immediately with an error. So in that case what happens, it does not have any child process, but still parent process is waiting for the child termination status. In that case also what happens, it return immediately with an error status. So we are using these two APIs usually, that is wait and wait PID. We'll see the difference here. The wait function can block the caller until child process terminates, whereas wait PID has an option that prevents it from the blocking, which means that if suppose the parent process is calling the wait function, then the parent process will be blocked even though the child process is not terminated. So in this case there is an alternate option we can use in the Unix system, is that by using the wait PID we can prevent the blocking of the parent process. It can do other tasks. The wait PID function does not wait for the child that terminate first. It has a number of options that control which process it waits for. That means assume that a parent is having the two childs, but currently the second child is terminated. It wanted to retrieve the termination status of the second child, but still the first child is running. In that case, if I am using the wait API, then it is not possible to get the termination status of the second child. But if I am using the wait PID function, then I have a one option, I can directly retrieve the termination status of the second child here. Okay. If a child has already terminated and is a zombie, wait returns immediately with that child status. Already we discussed what do you mean by zombie process. Initially what happened, the parent is not waiting for the child process. In that case, child is entered to the zombie state. If it is already in the zombie state, the parent later on retrieve the status by calling the waiting. Otherwise, it blocks the caller until the child terminates here. If the caller blocks and has a multiple children, wait returns when one terminates. Means sometimes what happens, if suppose there is a multiple children are still running, so in that case wait is blocked the caller until one of the child terminates. For both wait and wait PID functions, the argument state location is a pointer to an integer. Means what the purpose of that pointer? If this argument is not a null pointer, the terminate status of the terminated process is stored in the location pointed to by the argument. Means if that argument value is not null, so where it is pointing in the memory location, in that location we are storing the termination status of that particular child process. So this is the one function we are using. The purpose of using this PR_exit function is how exactly the child is terminated, whether it is a normal termination, whether it is a abnormal termination. Is it the process is stopped by due to some reason? What is the reason for that? So everything we can get it. Just we can find it. Here W stand for wait function if exited, that is okay. Here also if W is exited status. In this case, just we can find signal. What is the signal responsible for that particular process is terminated? Here stopped. Just we can find it here. In this case also the process is not terminated, only stopped. We can say that pause. So we wanted to get the details of that, then we are using the PR_exit function. So there is a program here. Just we can go through this program. Here we are creating the one child process. If it is failure, then this statement is executed. Then we are allowing child to execute here. Then exit of 7. Next, we are calling. The parent process is calling the wait PI to get the terminate status of the child process here. Next, if it is failure, this statement is executed. Otherwise, PR_exit means this function is executed here. Currently status is 7. So what is the reason for that? Then it will retrieved and displayed on the screen. Then one more example here. PID is equal to 4 is nothing but one more child we are creating and we are allowing child to execute. Then abort. Then obviously this what I can say that the child is terminated due to abort signal. So for this case, this statement is executed. This one is executed here. Okay. First case, this one is executed. Next, here in this case, this one, if process is stopped, is unflow, we are performing the divide by 0, then routing part error. In that case, the process is stopped, its execution. So once again, we are calling the PR_exit. Then one, we are in this case, this statement is executed here. Okay. So with respect to the wait PID function, the interpretation of the PID argument of the wait depends on one of the value here. If suppose PID value is 1, waits any child process. In this respect, wait PID is equivalent to wait here. Any process, not any particular process. If PID is greater than 0, waits for the child whose process ID is equals to PID. Means if suppose I am having the 4 value, so it is waiting for that particular child process. If PID is equal to 0, the PID value is 0, waits for any child whose process group ID equal to that calling process. Means child group ID is also same as that of the parent group ID here in this case. Next, waits for any child whose process group ID is equal to absolute value of the PID. That is nothing but say for example -4, the absolute value of that one is 4 here. Okay. The wait PID function provides the 3 features that are not provided by the wait function. The wait function let us wait for one particular process, whereas the wait function returns status to any terminated child. Means by using wait PID function, we can wait for a particular process, but it could not happen by using wait. The wait PID function provides the non-blocking option. Means wait PID function is having the option non-blocking, but wait could not have a non-blocking option, only it is having the option is blocking here. The wait PID function proposed the job control. Means it is a third argument, it is an option, it is providing untraced and uncontinued and no hang. So if suppose currently the child process is with respect to job control, so in that it is getting the details of that child process, what is the job control information. Okay. We'll continue in the next video.